Example 3, find the standard form of the equation of the hyperbola that has vertices and foci. Standard form of the equation of the hyperbola, those words mean that we want to create a hyperbola. Now, there's two different standard forms. Before I establish a standard form, I want to get an idea of the information they give me. Is it up and down, down or left and right? So I know what the plus and what the minus is. So if I plot what they give me, 0, 2 vertex, 0, negative 2 vertex, 0, 3 focus, 0, negative 3 focus, and I put an F and a V and a V and an F. So identify what they are on my graph. I can see since the foci and the vertices are vertically positioned, it's going to be an up and down hyperbola. That tells me immediately there's going to be a y minus k squared over b squared minus x minus h squared over a squared is equal to 1. And be very careful with hyperbolas. Again, we just got done with the ellipse chapter. A was always under the first one, B was always under the second one. That's because the first one was always x, the second was always y. A is always under x, B is always under y. And sometimes with order, B ends up on the left-hand side. So again, sometimes we get stuck in kind of a pattern of things and we start seeing things that aren't really there, so be careful. So the center is positioned halfway between the vertices and the foci, so obviously the center is going to be 0, 0 here. So that tells me that h is equal to 0, k is equal to 0. I need to know a and b also. Alright. And obviously b is equal to 2, because the vertices are 2 spaces up and down. So again, knowing what to look for helps you to establish what things are. What I can see though is I don't have any information for A, but I do know that the distance from the center to the focus is 3, and that's equal to C. So I need to know these 4 green things, but knowing the value of C is not going to hurt me because I have a relationship between A, B, and C. So if I'm able to find 2 of these 3 values, A, B, and C, I know that a squared plus b squared equals c squared. Friendly little formula that we remember from the Pythagorean theorem. It's just coincidental. It's the same, but it's just not because of the same reasons. But a squared plus b squared equals c squared. So a squared plus 4 is equal to 9. Squaring 2 and squaring 3 for b and c. So a squared is equal to 5. And again, if I can figure out a squared, that's fine because that's what goes in the formula anyway. I just know that it's, identify it that way so when you actually start writing your answer out, you put the right numbers in the right spots. So h and k are both 0, a squared is 5, b is 2. Again, in order to answer the question, I have to know which standard form to use and what the important values are. Once I have all the information, I write my answer. I don't write minus zeros personally, so I'm not going to write y minus 0, I'm just going to write y squared over b squared, that'll be 2 squared, which is 4, minus x minus 0, which is x squared, over a squared, which is 5, equals 1. Again, if I get a 0 for a coordinate on center, I don't put that in my standard form. I just write it like that. If you want to put y minus 0 parentheses squared and x minus 0 parentheses squared, that's all fine. There is an equals 1. Make sure the equals 1 shows up. Every year, 1 or 2 students just forget about the equals 1. It's one of those forgettable things, but it's part of the formula that's necessary. It needs to be there.